Hi, this is homework number 9, problem number 1. Z of t equals to n1 of t times cosine omega ct plus theta minus n2 of t sine of omega ct plus theta, where theta is uniform from 0 to 2 pi, n1t and n2t are WSS processes, and n1t, n2t, and theta are all independent. Okay, so in problem A, we're asked to find the expected value of z of t. So we have to go back to what we know. So from the problem, what we know automatically is since n1t and n2t are Wyatt-Son stationary stochastic processes, the expected value of n1t is equal to eta 1t, which also equals to eta 1. Eta 1 is a constant. Same thing goes for n2t. Expected value of n2t equals to eta 2. And so we were going to explore part A, which is right here. Gonna move this up a little bit. So we're trying to find expected value of zt. Okay, so how we investigated this was to pretty much put this entire function into the expected value. And so once we do that, since they are linear, or excuse me, not due to linearity, since they're independent, I could set that as the expected value, separate them into separate expected values, and then same thing over here in the third row. I can do that again with the theta, because in the beginning of the problem they said that n1 of t, n2 of t, and theta are all independent. And eventually I arrived, so right here, expected value of n1t, as we said before, is equal to a constant eta 1, so I put that right there. This right here equals to this. Same thing goes for expected value of n2t. Let me put a parentheses around that. Right here we have eta 2, okay? And this expected value of cosine omega ct plus theta is actually also equal to the integral from 0 to 2 pi cosine omega ct plus theta d theta. And same thing goes for here, sine of omega ct plus theta d theta. This whole thing, if you take the integral of cosine or sine from 0 to 2 pi, it's always going to equal 0. The resultant area of the graph is going to equal 0. Therefore, you have eta 1 times 0 plus eta 2 times 0, which equals to 0. Therefore, the expected value of zt equals to 0. And that is part A. Now, moving on to part B. I have a couple pages, so please bear with me. The question is asking, find r subscript z of t1 comma t2, and it is asking furthermore, is zt a Wyatt-Son stationary stochastic process? So right here we have, I restated the question, and for t1 and t2 I converted this function into the expected value of z of t1 times z of t2. So right here in the original function of zt, for every t there, z of t1, you replace every t with t1. Same thing for z of t2, replace every t with t2. Okay, so these are our two functions, and basically it's a lot of work, but we FOIL them out. After I FOILed everything out, if you want to take a moment to maybe pause the video, you can see what I FOILed out. I FOILed it out to these 4 terms, 1, 2, 3, and 4. Okay, furthermore, I simplified it. Remember how we talked about, so in these two, in the second and third terms, the negative terms, we have eta. Remember, so we know that the expected value of n1t is equal to a constant. Expected value of n2t is equal to a constant. Same thing we're applying right here. We know that these are expected. Sorry, it's messy, but if you take a moment to pause, you can see my work under there. Expected value of n2t2 is n2 or eta 2. Expected of n1t1 is eta 1. Same thing over here. Expected value of n2t2 is eta 2. Expected value of n1t1 is eta 1. So that was like the first thing that you saw. Over here, it's good to note that expected value of n1t1, n1t2 is basically expected value of or the r of n subscript 1 of tau. Tau is equal to t1 minus t2. Same thing over here, r of n2 of tau. Again, tau is equal to t1 minus t2. So I simplified those processes to the r function. Can't forget about the second part. We have still setting this equal to the expected value of cosine omega c t1 plus theta times cosine omega c t2 plus theta. And so same thing for all this. I worked it out. Sorry, I had to squeeze the e in there. I forgot to add it in when I was doing the workout for this video. So now that we have these four terms sort of simplified, we're going to simplify it even further. Right here. This actually takes up the whole screen. Okay, so right here is what we have, again, before when I simplified it, r, n subscript 1 of tau, e, basically restated everything right here, just for simplification purposes. And this is basically this, what I showed you before. So you can sort of take a look at it. Basically, I just wrote it out so it's nicer, so that we can continue the problem on a new page, okay? And so we, as you can see, I added the side note over here, just in case that I forgot, or you forget that tau is equal to t1 minus t2, okay? There's another side note. In order to simplify this further, you need to use the trigonometric identities. Cosine of alpha plus beta equals a cosine alpha, cosine beta minus sine alpha, sine beta. Cosine alpha minus beta equals a cosine alpha, cosine beta plus sine alpha, sine beta, etc. Pause the video if you want to take a look at the trigonometric identities. And so I use this to simplify what was in here. And so here you have your alpha and your beta, but just squared. And so if you take if you convert this into convert this using a trigonometric identity, you eventually arrive at another expected value, which I converted to a integral, which is shown right here. So after I converted these four pieces into integrals, the signs also change. These two actually cancel out. And you're left with this function and this function. And basically these two functions are just RZT. This is the answer to the original question of part B. RZ of T1, T2 equals to Rn1 of tau over 2 cosine omega C tau plus R2 tau over 2 cosine of omega C tau, sorry. And to further simplify this, I just pulled out the 1/2 and the R1 tau plus R2 tau and the cosine omega C tau. But as you can see, this is all a function of tau, so therefore Z of T is a wide sense stationary process. And finally, for part C, since in part B we proved already that Z of T is a wide sense stationary process, you basically just plug in where there's tau, you plug in 0. So cosine of 0 is going to be 1. Okay, so you kind of leave that alone, and R1 of 0 is basically 1/2 times R1 N1 of 0 plus R N2 of 0, which equals to 1/2 times the expected value of E N1 squared T plus E N2 squared T. And that is homework number 9, problem number 1. Thank you.